Now there's one more addition that we could set up very easily when it comes to the light instancing. Now the current behavior is very static. We can only use the starting position of the path. We're basically only taking the first line before the first term. Another good approach would be to import the real camera position and use its proximity to the light. But I want to keep the camera separated from this. So here's another way to make it more controllable. Copy this wrangle and this will delete the points dynamically. And this is a really simple adjustment. Instead of always using the first point of the path, we're using an input parameter called pt and then see what happens if we increase that value. As soon as we reach the point of the next corridor, that line gets active. Then we only need to connect this wrangle to the one that is responsible for the deletion of the lights. Nothing has changed for this wrangle, so it works right away. But there's another way to create even more control. So copy this wrangle again, and this time it will delete the points with an offset. Instead of using a specific point position to determine if the current point is removed, we use the point number of the input we created. If the current point has a higher point number with an optional offset, then we're going to remove the point. What does that mean for the points on the path? Simple. All the lights that lay beyond the input point are deleted. That also means we can directly control how many lights and how far into the corridor are active. With the offset parameter, we can then increase that range. That's one effect for the lights that could already be interesting, but I think it could be even more interesting if we could also deactivate the points that we no longer need because we passed them. All we need for that is another if condition where we now check if the point number is smaller than the input parameter. And with that we have direct control over the trigger that activates and deactivates lights. As with the first addition, this offset also directly works as soon as it's connected to the outgoing wrangle. Now we have a full light array with full control over its position, and that also means we can put in an expression that makes this input time dependable. For example, the current frame divided by 3. When we now leave the instance node, bring the viewport in position, and then move the playhead, you can see how the light array moves approximately with the same speed as the camera, and this will create a really interesting effect. Another way of looking at this, if we deactivate the path camera and also hide the path, and assume we have a static position, the light array creates a light trail animation. And this was it. Our sci-fi corridor generator is finished.